So if you go to the course website, this is the course website. It contains tutorial sheet 2, which is this one, right? There are 7 questions. I will try to do as many as I can. I may not be able to do all of them, but you will see, I mean, I will post the full solutions to all the questions on the course website later this week. So you will be able to see solutions. You'll be able to see solutions to all 7 questions later this week. Okay. All right, guys. I don't know whether you guys whether you guys attended the review session. The videos for the review sessions are already online. So these are the 2 videos for the review session that took place this morning, and also the handwritten notes for the review session is here, and the videos for the tutorial that took place this morning is this one and this one. All right. Okay, guys, let's stop this and let me change the camera now. So let me change the camera to this, right? Excuse me. All right. So this is the tutorial sheet. I will start with question number 1. Okay. I hope you guys you have a copy of question 1. I mean, you can see it in your laptop what question 1 is, right? Question 1 is about whether a sample is representative or not. Like you're given a sample and you're asked to check whether it's a representative sample or not, right? So for part one is saying poll all people of voting age attending a local football club. That is not a representative sample because it's not a representative sample because not every voter likes football. All right. By the way, if you have any questions, feel free to use the chat room. I will answer your questions as quickly as possible. Right? Okay. Okay. So that's part 1. Part 2. Part 2 is asking you whether all people of voting age who are living in expensive restaurants on a particular evening. That's clearly not a representative sample because not every can afford an expensive restaurant. Okay, that's part 2. Now part 3 Part 3 is saying obtain a copy of the voter registration list and randomly choose 500 names and question each of them about their voting intentions. Okay, part 3 is a representative sample. Okay, and part 4 is use the results of a telephone poll in which a television station asked its viewers to call and state their voting preference. This is not a representative sample. Right, because not every voter may have a telephone. I know it's unlikely, but there are people not every voter may have a telephone. Okay. All right, so that's part 4. Finally, part 5, choose 200 names randomly from a telephone directory and call those people. And that's clearly not a representative sample because not everyone likes to be listed on the telephone directory. Okay, so this completes the question number 1. Anything you'd like to ask, guys, before I go to question 2? Are you guys okay with this or no? Do you have any questions, please? Feel free to talk to me, guys. Hello, guys. Are you okay with question 1? Yeah, okay, thank you. All right, next question 2. Question 2 is similar to question 1. Again, you're asked to check whether each of these is a representative sample or not, right? So let's start with part 1. In part 1, says to determine what the average person spends on a vacation, a market researcher interviews passengers aboard a luxury cruise liner. And clearly it's not a representative sample. Right, because only the rich can afford a luxury cruise liner. All right. Okay. And part 2 is to determine the average income of graduates 10 years after graduation. A university sends questionnaires in 2015 to all members of the class of 2005 and bases estimates on the questionnaires returned. Okay, here is again, it's not a representative sample because I will tell you why, because graduates are not likely to report their true income. Right? Because, for example, if somebody earns like, say, £1 million a year, then they may think it is too posh to report that. And on the other hand, if somebody earns, say, £10,000 a year, they may think that's too little and too embarrassing to report that. Okay, so they may not report the actual income. So this is not a representative sample. All right. Part three is this: to determine public sentiment about certain import restrictions from a particular country, an interviewer asks voters, do you feel that this unfair practice should be stopped? All right, here the wording of the question is not fair, because this is not a representative. It's not because of the wording. Of the question. Okay, you see, the question is worded in such a way that the question is like this: do you feel that this unfair practice should be stopped? So people are likely to say yes, even if they think it's no, right? So the answers are not likely to be representative because of the wording of the question, right? Okay. All right, guys, are you okay with this? Question 2. Hello, guys, talk to me. Are you okay with this or not? Yes, all right. All right, so I'm done with question 2. Now let me move to the next question, question 3. If you have any question, just feel free to use the chat box. All right, this is question 3. Question 3 has 3 parts, right? The first part is to calculate the population mean. The second part is to calculate the population variance. And the third part is something more, right? Okay. So the population that you have here is the following. Population is 2, 3, 6, 8, 11, right? So, and you're choosing a number at random. So that means that the number can be any of these: 2, 3, 6, 8, or 11. And the probability associated with the number, because there are only 5, so the probability is going to be equal. Okay, the probability is going to be equal. So to find the population mean, which is the expectation, the same as the expectation, all you have to do is multiply this with this and then sum. So it's going to be and this will be equal to 6, right? So this completes part 1. Right, to do part 2 is to find the population variance, which is the variance of x1, which you can write as like this, right? Now, this guy we already know. is 6, so 6 squared is 36. Now this guy is, we can compute using the table. Okay, now if you compute this, you will get this to be 10.8. All right, so these are the first two parts of question 3. Now the last part of question 3 is this, right? By considering all possible samples, calculate the mean and the variance of X bar. Remember, we are drawing samples with replacement, right? Okay, so that means the possible outcomes that you can have are going to be, when you draw with replacement, you can have all possible outcomes, right? So let me write down the outcomes that you can have first. Outcomes for x1. x1 is the first number that you choose. x2 is the second number that you choose. And then you have x bar. X bar is the average of the two. Okay. This will be the first outcome, 2, 2. Remember, we are drawing with replacement, right? All right, 2, 8, 2, 11. Let me know if I make any mistakes. Please let me know, guys. Then you can have 6, 2, 6, 3, 6, 8, 6, 2. Sorry, I left out 6, 6, 6, 6, 8, and 6, 11. Right, and then you can have 8, 8, 2, 8, 3, 8, 6, 8, 8, and 8, 11. And finally, you can have 11, 2, 11, 3, 11, 6, 11, 8, and 11, 11. So these are the possible outcomes that you can have. In total, there are 25 possible outcomes. Now what we need to do, we need to compute X bar for each of these possible outcomes. So for the first pair, X bar is 2. The second is 2.5. The third is 4. Then 9.5, correct me if I'm wrong, 7, 8.5, 9.5, and 11. So what I have done is a table of outcomes and the corresponding values for X bar, right? Okay, the next thing you need to do, guys, is the following. The next thing you need to do is to draw a table of different possible values for X bar and the corresponding probabilities. Now, some of these values are repeated, right? So the distinct possible values for X bar are as follows: 2, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, and 9.5 and 11. So these are the different possible values for X bar. Now for each of these, I'm going to write down the probability. For 2, there's only one outcome that corresponds to 2, namely this one. All right, so the probability is 1 divided by 25. For 2.5, there are 2 outcomes with 2.5, namely this one and this one. Both of them have 2.5. So the probability is 2 divided by 2 divided by 25. Next one, 1 divided by 25, 2. Okay. Then you guys okay? If you don't follow something, please let me know. So you see what I've done here. I created a second table with the first column giving the values for the different possible values for X bar, and the second column gives the probabilities, right? Now what I need to do is to find the expectation of X bar. To find the expectation of X bar, I just multiply this column with this column and then sum. All right. Okay. And if you do this, you will get this to be equal to 6. All right. The next thing is to find the variance of X bar. Right, to find the variance, I'm going to use the formula that I mentioned to you a while ago, which is this one. Right. So this is going to be 36, right? And this guy, we can find it similarly as 2 squared yeah, and if you compute this, this will be equal to 5. So the mean is the expectation of X bar is 6, and the variance of X bar is 5.4. All right, guys. Any questions? So this completes question 3, guys. Any questions on this before I move to question 4? Are you sure, guys? All of you? Okay. All right, so let's move to question 4 now. So we're done with question 3. So question 4 is this one. It's basically a continuation of question 3. The only difference here is that, remember here we did it with replacement, but here we're gonna do it without replacement. So the difference is that we're gonna draw the sample without replacement, okay? So let's see what happens. This is question 4. All right, the first thing we need to do is the table of outcomes. Outcomes for X1, X2, right? And then the corresponding values for X bar. Now the possible outcomes for X1, X2 is gonna be this: 2, 3, 2, 6, 2, 8, 2, 11, 3, 6, 3, 8, 3, 11, 6, 8, 6, 11, and 8, 11. Now you may see that I have put 2, 3, but not 3, 2. I have put 2, 6, but not 6, 2. The reason is that here the order does not matter. The order, I mean, even if you will get the same answer, even if you include 2, 3, and 3, 2, and 2, 6, and 6, 2, the answer will be the same. So the order does not matter, or the order will not change the answer, right? Okay, that's what I mean. All right, now let's compute x bar. So this is gonna be for 2, 3, x bar is 2.5. For this is 4, 5, 6.5, 4.5, 5.5, 7, 7, 8.5, 9.5. All right, so these are the averages, these are the outcomes. Now the next table is gonna be this. All right, the first column is gonna list the possible values for x bar, which are 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, 9.5. These are the distinct possible values for x bar. The corresponding probabilities are these. All right, you see, 7 occurs 2 times, except for 7, all the others occur only one time. 7, so you have 2 7s here. That's why you have 2 out of 10, right? Okay. All right. Now the next thing I'm going to do, is to compute the mean and the variance, right? Okay. So let's do that. So the expectation of x bar is simply this multiplied by this and then take the sum. So it's 2.5 multiplied by 1/10 up to 9.5 multiplied by 1/10. All right, and if you do the math for this, you will get this to be 6. Now the variance of x bar, is the same as before, is the expectation of this minus the square of this, right? To compute this, I'm going to use this table one more time. So it's going to be 2.5 squared times 1/10, 9.5 squared times 1/10, minus the square of this, which is 36. Now, if you do the math for this, you will get 4.45. So you see, if you compare this with the results that we got earlier, now in question 3, we did the same question with replacement. Now this is without replacement. So the mean is the same. The mean was 6 in question 3, and it's still 6 in question 4. But the variance has changed. The variance was 5.4 in question 3. Now it is 4.05. So what you can say is the following. The means are the same. The means are the same, right? But the variance is smaller. Is smaller for without replacement. Right? The variance is smaller for without replacement. You see, the variance in question 3, was 5.4. Now it is 4.05, so which is smaller, right? All right, so that completes question 4. Are you guys okay with this or not? Any questions on this, guys? Just talk to me. Hello, guys. Are you okay with this question? Oh, good. Okay, thank you. All right, so let's move to the next question, which is question 5. I hope all of you guys are okay. This is question 5. So here you have 5 numbers: 3, 7, 5, 11, and 15. The first part is to calculate the population mean. and so on. Okay, so let's see how we can do this, right? So this is question 5, part 1, right? So the population mean, so the population consists of the following numbers: 3, 7, 9, 11, and 15. All right, so these are the numbers that we have. So when you pick a number, the possible outcomes can be either 3, 7, 9, 11, or 15. The corresponding probabilities will be 1/5, 1/5, 1/5, and 1/5. All right, so the population mean is gonna be, right, 3 times this. So you multiply these 2 columns and add them. Okay. All right, and you should do the math. You will get this to be 9. Okay. So that completes the first part. Now to do the second part, we are picking 3 numbers without replacement, and we want to find the distribution of X bar. All right. So let's see how we can do this. This is part 2 of question 5. So the first thing you need to write down are the possible outcomes and the possible values for X bar. So you have 2 columns. So the possible outcomes are 3, 7. This is the first possible outcomes. Again, the order does not matter, because even if you take the order into account, you will get the same answer. All right. So the order does not matter. One more time here. Right. So these are the possible outcomes when you pick 3 numbers out of this population, right? The corresponding probabilities, sorry, the corresponding values for X bar are as follows. This is 19/3, 21/3. So you just take the sample mean, right? 29/3, 27/3, 31/3, 33/3, and 35/3. All right, so this is the first table that you need to do. The second table that you need to do is the following. So you need to list the possible values of the different distinct values for X bar, and also the corresponding probabilities. So the distinct values for X bar are as follows. All right, these are the distinct values for X bar, and the corresponding probabilities are these. You have 2. There are 2 outcomes with 27/3, namely this one and this one, right? And the others have only 1 each. Okay. Okay, so this is, so from this table, you will be able to work out the the expectation and the variance, right? So that's what I'm going to do. That's what I'm going to do now. So the next thing I'm going to do is to work out the expectation of X bar, right? So you just multiply this column with this column and then take the sum. Right, and if you take the sum, that will be equal to 9, right? And to find the variance of X bar, you use this formula here. You have seen this enough times, so okay. Now to compute this, I'm going to use this table one more time. So that's going to be 19 by 3 squared okay, minus the square of 9, which is 81. All right. Okay, so now if you simplify this, this will be 2.667. Right, so that's the variance of X bar. All right, so that completes one part of part 2 of question 5. Now part 3 of question 5 is this. Now list possible outcomes and calculate the mean and the variance of the sampling distribution of the sample median, right? So here we are talking about sample median, not sample mean, right? So to do part 3, you need to rewrite the tables, right? The outcomes, these are the outcomes and the corresponding values for the median. All right, so let me rewrite the outcomes. 379, the first one. The second outcome, 3711. The third, 3715. 3911. 3915. 31115. 7911. 7915. 71115. And finally 91115. So there are 10 outcomes, right? The corresponding, remember the median is the middle number when you arrange the data from the smallest to the largest. The median is the middle number, which is 7, 7, 7, 9, 9, 11, 9, 9, 11, 11. So these are the possible values, the values for the median. Now the second table that you want to do is the following. Here you list the different possible values for X bar and the corresponding probabilities. Now there are only 3 different values for the median, 7, 9, and 11, right? And the corresponding probabilities are 7 occurs 3 times, the first 3. 9 occurs 4 times, so it's 4 out of 10. And 11 occurs 3 times, so it's 3 out of 10. All right, so this is the table that we need. So to find the expectation of the median, the sample median, all you have to do is just multiply this with this and take the sum. So it's going to be this, and this is equal to 9, right? And to find the variance of the sample median, right, you use the same formula that I used before, that is Okay. All right. Now, this one we already know is 9. 9 squared is 81. And this one, to find this one, you just say 7 squared okay. And if you compute this, this will be equal to 2.4, right? Okay. All right, guys. So the comparison is as follows. You see, this is the mean. I don't know if you can see this. All right, this is the mean for the sample mean, which is 9. And the mean for the sample median is also 9. So they are equal. But the variance for the sample mean was 2.667. Now for the variance for the sample median is 2.4. So what you can say is the following. So this is part 4 of question 5. The means are the same. Okay, the means are the same, but the variance is smaller for the sample median. All right, you see why, because the variance is 2.4 for the sample median, whereas the variance for the sample mean was 2.667. All right, so you see what is happening. Okay. All right, so that completes question 5. Now let's move on to question 6. Let's see. By the way, do you have any questions on question 5? Any questions on what I have done? Okay, guys, thank you. Okay, let's go to question 6. Question 6 is this one. Question 6, you have a random sample from a uniform distribution and calculate the mean and the variance of the sampling distribution of X bar. All right, it shouldn't be too difficult. Let's see how we can do this. This is question 6, right? All right, the mean is, as you know, you have a sample of size 10, right? Okay. Now, if you take the expectation inside, this is gonna be this, right? Okay, guys. Now, we have a uniform distribution 0, 1. So the density is 1, right? It's a continuous uniform. So you integrate to find the expectation of xi. You integrate from 0 to 1 of x times 1 dx. Right. So this is gonna be 1/10. If you integrate this, you get x squared by 2. The limits from 0 to 1. Right. So this is gonna be once you take the limits, you get half, right? Half minus 0, which is half, right? And this will be 1/10 times 10 by half, right? Which is equal to half. the population mean of the sample mean is equal to half. Right now, to find the population variance, you do something similar, right? To find the population variance of X bar, you take the variance of this, right? Now taking the variance inside, 10 becomes 100. Okay, now variance of xi, we can compute it as the expectation of xi squared minus the square of the expectation. Okay. Okay, to compute this expectation, you just do integral from 0 to 1 of x squared times 1 dx, right? To compute this, which you have already done anyway, I will just write it again anyway. So it's the integral from 0 to 1 of x 1 dx. Okay. Now the integral of this is x cubed by 3. You take the limits from 0 to 1. Okay. The integral of this is x squared by 2. You take the limits from 0 to 1, and then you square it. Okay. All right, guys, are you guys with me? This is simple integration. So this is 1 over 100 times 1 to 10. Now, after taking the limits, you get 1 divided by 3, and here you get 1 divided by 2 squared. Okay. So this is gonna be this is 1 over 3 minus 1 over 4, which is 1 over 12. Okay. All right, so this is 1 over 100 times 10 times 1 divided by 12, which is 1 divided by 120. So this is the population variance of X bar, and this is the population mean of X bar. All right, guys, so that completes question 6. Question 7, I don't know whether I have time to do question 7. Question 7, there's a typo in question 7. I don't know whether you noticed that. There should be a X6 on the left-hand side. But it's not difficult to do question 7. I mean, let me see. Did you guys try to, sorry, did you guys try to do question 7 or not? Question 7. Question 7 is to find the joint probability that you have six observations from a Poisson distribution with parameter lambda. Okay, all right. So basically, it's like this. What you have is product 1 to 6 of E minus lambda power xi divided by xi factorial, right? And if you take the product of this, you get E minus 6 lambda power sum of xi, I from 1 to 6, then divide by the product of xi factorial, I from 1 to 6, right? Okay, now you should sub in the numbers. You are given the different values for x, right? So you should sub in the numbers. This will become e minus 6 lambda. Lambda, the sum of xi, the sum of these numbers is 59, right? Divided by 9 factorial, 13 factorial, 6 factorial, 8 factorial, 10 factorial, and 13 factorial. So these are the different numbers that you're given. Now the question is asking you, if lambda takes 10 or 12, which one is more likely? All right, now to answer that question, let me call this star. Now if lambda is equal to 10, then if you have a calculator, you can work out the value for star to be this. And if lambda is equal to 12, then star turns out to be equal to this, right? And hence, the value that is more likely is the one that has the higher probability, which is this one. So the answer is that lambda equal to 10 is more likely to occur, okay? That's because that has a higher probability. 5.9 or 7 is greater than 1.709, okay? So that completes question 7, and it also completes the tutorial sheet number 2. Right, guys, do you have any questions on any of the questions I've done today? Are you guys okay or not? Are you sure? No. Thank you, guys. So I will post the video for this tutorial on the course website. By the way, all the videos, I said this many times, all the videos for all the sessions are on the course website, which I'm sure you guys know. It's not Blackboard. I don't use Blackboard for videos. I use my course website, which is minerva.manchester.ac.uk/my name, right? My first name. Lambda, sorry, this is lambda to the power 59, Jess. It's 59 because the sum of xi is 59, Jess. So if you sum the values for x's that you're given, you will get 59, right? That's why I have written 59 here. I hope you follow me. Yeah. Yeah. All right, guys. So have a great evening wherever you are. And I'll talk to you soon. And as I said before, any questions you guys have about this course or related, call me, right, 24/7 by phone or email or Zoom or Skype, right? Okay, have a great evening.